Hello everyone. Last class we discussed about a parallelogram law and we were saying that the next class we are going to discuss what are the special cases of parallelogram law. So I'm just revising what we told in last class. Whenever you are having a vector like this, we will mark a vector and we will call it by the name vector A, and you are having another vector, we call it by the name vector B, and A and B are making an angle. That angle we call it by the name theta. We will construct a parallelogram. So we will draw a line parallel to A. Then we will draw a line parallel to B. Then we will construct a diagonal. So the diagonal will pass through like this. This diagonal we call it by the name resultant R, vector R. So this resultant will give you the vector A plus vector B. That value will be provided by the resultant. Fundamentally, as I told you, what is the total vector, or they are asking what is the net vector they are asking. We are actually doing vector addition. Suppose a block is acted upon by 3 forces and they are asking what is the net force acting on that body. Then you have to find F1 plus F2 plus F3. You are going to add them, but you have to use a parallelogram law. Vectors will not obey ordinary rules of algebra. So if I try to add vector A plus vector B, then the resultant R has a formula. We know magnitude of resultant R, as last class I told you, A square plus B square plus 2AB cos theta, and this value will give you magnitude of the vector. A vector will have a magnitude as well as direction. So if you apply root of A square plus B square plus 2AB cos theta, you are going to get a magnitude of the vector. And similarly, suppose this angle it is making with A, let us call alpha. Then alpha is called direction of the vector. So if you want to find tan alpha has a formula directly, B sin theta divided by A plus B cos theta, and this thing will give you direction. Usually in mechanics and all, direction doesn't mean south, east, north, west. It fundamentally means angle with respect to horizontal, that is called direction alpha. As I told you, whenever we are advancing in mechanics, we cannot always apply this formula. We need some easy shortcut ideas. So we are going to study some special cases, commonly repeated things in mechanics. So regarding special cases, we will see some special cases as well as examples. In special cases, let us see case 1. In case 1, what we are going to say is that vector A and vector B, vector A and vector B are parallel. Let us consider A and B both are parallel to each other. For an example, here I am drawing. Suppose this is my vector A like this, and this is my vector B like this. Vector A and vector B. Here you can see A is towards right, B is towards right, both are along the same direction. When two vectors are along the same direction, I want you to understand the angle between them, we call theta, is taken as 0 degree. So if theta is 0 degree, let me put in R equation, resultant equation, that will be root of A square plus B square plus 2AB cos 0. Theta is 0 degree. We all know cos 0 value is 1. So this thing will become root of A square plus B square plus 2AB is fundamentally A plus B the whole square. Root and square will cancel out. Your answer will be simply A plus B, which means when two vectors are parallel to each other, you can directly say the resultant of the vector will be simply addition a plus b. So that is the first point I want you to remember throughout the mechanics. Whenever two vectors are acting in the same direction, if I ask you the net value, you have to simply add them. A plus b will give you the value. And here there is no confusion. Since a is towards right, b is towards right, that resultant, that is our a plus b, resultant will be always directed towards right. As an example, I am going to show you one figure. Suppose in this question, I am going to draw a rectangular block like this. In this rectangular block, we are applying two forces. So one force here I applied, let us say 20 Newton, and another force I applied, let us say 12 Newton. I applied like this. And the question is to find what is the net force they are asking you. Net force is fundamentally summation. Net means summation of this value. So I want to add a vector 20 plus vector 12. Since both are in same direction, you apply the formula a plus b. So I can directly write 20 plus 12. I am going to get 32 Newton as my answer. If you ask me in which direction this 32 Newton will be acting, we know 20 towards right, 12 towards right, therefore a plus b will be also towards right. So this 30 Newton force will be acting towards right, not 30, 32. So this 32 Newton force will be acting towards right. What is the meaning of this thing is that you can remove this 12 Newton, you can remove this 20 Newton, you can simply keep the 32 Newton instead. So using vector addition, we are simplifying a problem. Suppose you are having 10 forces. It is very difficult to analyze 10 forces. You make the 10 forces into a single force, then do the problem. Here you already had a 2 forces, 20, 12. I made it into a single force 32. Now I have to only deal with that 32. So this is the reason we are studying vector addition. We will move on to the next example. Next example, case 2. In case 2, what we are going to say is when vector A is anti-parallel, vector A is anti-parallel to vector B, which means both are in opposite direction. That is the meaning. So vector A may be towards right. So vector A towards right, while vector B may be towards left. This is your vector B towards left. When two vectors are opposite to each other, I want you to understand the angle between them, theta, we will take it as 180 degree. Then we will apply in our resultant formula. R is equal to root of a square plus b square plus 2ab cos 180 will come. We know cos 180 has a value minus 1. Cos 180 minus 1 means this value will come as root of a square plus b square minus 2ab. You know this is a minus b whole square expansion. Therefore directly we can put this will be a minus b the whole square expansion. If you take a root, your answer will come as a minus b. Therefore our next point we got, when two vectors are in opposite direction, the resultant vector is simply a minus b. You have to subtract them and that will be your answer. In this situation, the direction is controlled by which is the bigger vector. If vector A is a greater one, it will be in the direction of A. If vector B is the greater one, it will be in the direction of B. For my convenience, in this figure I am assuming vector A has more value than vector B. So A is dominating. Since A is dominating, the resultant vector will be in this direction. Along the direction of A, you can mark your resultant vector. Now let us see one example. In this example, we are going to take a rectangular block like this, and let us apply forces. Here one force is acting. This force may be 30 Newton, and here another force is acting. This force may be 10 Newton, and we need to find what is the net force acting. We know force is a vector, it will follow vector algebra. According to vector algebra, when two vectors are in opposite direction, net value is A minus B, as we have written. So you take the higher value minus lower value. 30 minus 10, your answer will be 20 Newton. And we need to understand this is only magnitude. Direction is given by the higher value. Here higher value is 30, which means your resultant will come along the direction of 30. This is equal to a net value of 20 Newton acting towards the left. As I told before, you remove 10 Newton, you remove 30 Newton, you can simply keep a 20 Newton towards the left to complete the problem. So two forces merged into a single thing, problem become easy. That is your A minus B value whenever two vectors are in opposite direction. Next, we will see the most common thing we are going to encounter. Most common thing is our case 3. In our case 3, it will be vector A is perpendicular to vector B. Both are perpendicular to each other. So let me mark like this. Maybe this will be our vector A, and this will be our vector B, like this, and both are perpendicular to each other. Okay, when they are perpendicular, we know already theta will be simply 90 degree. We can keep like this. Then resultant R we can directly find using the formula root of A square plus B square plus 2AB. What is the angle here? The 90 degree, and cos 90 has a value 0. Therefore directly R is equal to root of A square plus B square. So remember, this is your resultant value. R is equal to root of A square plus B square when two vectors are perpendicular to each other. If you want a direction, we can complete a parallelogram. So in this case, if I complete a parallelogram, here it will come like a rectangle. The diagonal will give you the resultant value. This is the diagonal, and this is your resultant value. And this angle is our alpha. If you want a tan alpha, that is a right angled triangle, isn't it? This is a right angled triangle. Therefore, I can take a tan alpha. Tan alpha is opposite side, that is B, adjacent side, that is A. From here we can easily find alpha. Alpha is equal to tan inverse B by A. So that is the value we can easily find whenever two vectors are perpendicular to each other. Let us see one common example here. Suppose if I am going to take a rectangular block like this, I will consider a rectangular block like this. In this rectangular block, we are applying one force. Let us say one force is acting. This is 4 Newton. And another force is acting. Let us say 3 Newton. Okay. And we are going to find, we know now both are perpendicular to each other. I am going to find the net force. If I am going to find the net force in this scenario, net force is equal to we can directly find root of a square plus b square, because whenever they are perpendicular, our value has to be root of a square plus b square. So it will be root of 3 square plus 4 square. Therefore, net force is 5 Newton. This is the peculiarity of vector addition. You give me, we are having a 3 Newton, 4 Newton. We are adding them, but in addition, our answer will come as 5 Newton. That is why it is a new type of mathematics. We should not hate it, we should embrace it. Because vector addition, once you mastered, almost every problems in mechanics will become very, very easy. We have scalar quantity, vector quantity. If you know what is a vector, if you know it is a vector, you know how to apply parallelogram law, then almost 50% of problems in mechanics are solved. Now, here in this figure, we need to find an angle also. Angle fundamentally means we can do like this. If I extend the forces and I am marking like this, the diagonal will be our answer. And now we know this diagonal is 5 Newton. Already we got. If you want to find how much angle, this angle alpha, we can directly put a tan alpha. Tan alpha is opposite side, that is 3, adjacent side 4. 3 by 4, if you take in calculator, approximately 3 by 4 is 37 degrees. So I understood that we can remove 4 Newton force, we can remove 3 Newton force, put a 5 Newton force, making an angle of 37 degree with the horizontal. Then you can do that problem. I hope everyone understood all the 3 cases, which are the most important one for us. There is one more case that we are going to see. In that case, that is usually not coming in examinations and all, but if you are remembering, it will be sometimes helpful. That is case 4. In case 4, what we are saying is that magnitude of vector A equal to magnitude of vector B, which means A and B are having same numerical value. A and B are having same numerical value, but directions may be different. That is the meaning of that thing. Directions may be different. So here I am going to show one example. Suppose if I take like this. This is our vector A. This is our vector A, and maybe this is our vector B. Let us say this is our vector B. Both are having same magnitude but different directions, and angle between them we can mark it as theta. Angle between them is theta. In this scenario, if I am going to find R value, resultant root of, I can put a square. Instead of b, I can put a square, because a and b are having same numerical value. Here I will get 2a square cos theta. From here we are values we are checking. A square will become 2a square plus 2a square cos theta. That 2a square we can take common outside. So root 2 will come, a will come. Inside root we will have 1 plus cos theta. And 1 plus cos theta, we are having a trigonometric identity, we can put it here. So it is root 2a root of 1 plus cos theta is 2 cos square theta by 2. That is a formula. So now you can understand what is the answer going to come. R is equal to root 2 into root 2 will become 2. A will remain A. Cos square and root will get cancelled out. You will get cos theta by 2. And that will be your answer in this case. Okay. So this maybe they will ask like a derivation for some universities and all. You remember that. And if I want to find alpha, how much angle. So if I construct a parallelogram like this and diagonal is going like this, we need to find what is this angle alpha. I will apply the formula for tan alpha. Tan alpha is, already we know the formula, b sin theta, but here b is a, b sin theta by a plus b cos theta. That is the formula. Here a you can cancel from numerator and denominator. So numerator only have sin theta. Denominator will have 1 plus cos theta. Likewise only it is going to come. And sin theta we can replace, cos theta also, 1 plus cos theta also we can replace. And if you simplify this value, I'm not going into trigonometric simplification, examination also don't go like that. Simply directly you put tan theta by 2. Okay, we will apply some formula. Sin theta is 2 sin theta cos theta. 1 plus cos theta also we will rearrange, cos square theta by 2. Then from there we are going to get the value. That's it. So if you want, you can, I can simply write sin theta will be what? 2 sin theta by 2 cos theta by 2. 1 plus cos theta is 2 cos square theta by 2. So 2 cancel, cos theta by 2, cos square will get cancel. Therefore sin theta by cos theta will become tan theta. That is what written. So I got alpha value is equal to how much? Theta by 2. I got alpha value is equal to theta by 2. This is the case. Okay, which means if I am having one problem, I am going to show you like this. Suppose we are going to, before that I will mark here also, which means now this alpha is simply theta by 2. Therefore we can say this remaining angle also will become theta by 2. That is why theta by 2 will become theta, which means resultant is bisecting the angle between the vectors. I am repeating, resultant is bisecting the angle between the vectors. Now as an example, if I try to draw a block again. So this is the block we are having. One rectangular block is present like this, and I am going to give this time one force is acting like this, that is 3 Newton. Another force is acting like this, that is also 3 Newton. That is the meaning A and B both are have same magnitude. If I want to find a resultant, directly I can put on the formula we written. What is the formula? 2a cos theta by 2. So 2a cos theta by 2. If I am putting 2, a is 3 here, cos theta by 2. Total angle between them is now 90 degree. 90, half of 90 will become 45 degree. And I can directly put 6 into, this will be 1 by root 2. 1 by root 2, your answer will come as 3 root 2 Newton. So you got a resultant value. Also both are perpendicular in order. So you can directly apply root of 3 square plus 3 square. Your answer will be 3 root 2. Case 3 also you can actually apply. And here things are very much fine only. We don't want to find the angle and all, because we know our resultant 3 root 2 will be bisecting the angle between the vectors. So this is your resultant. That resultant is 3 root 2 Newton. It is bisecting the angle. Total angle how much? 90 degree. Half of that. So we can say it will make an angle of 45 degree. And this will also make an angle of 45 degree. Total it will make 90 degree. So I think now everyone understood the essential cases of parallelogram law. If I am going in reverse order, case 4, I have said that when A and B are having same numerical value, resultant formula, also the resultant will bisect the angle between them. When A and B are perpendicular to each other, very important for us, resultant is root of a square plus b square. Alpha is equal to tan inverse b by a. Tan inverse vertical vector by horizontal vector. That's it. Next, when two vectors are in opposite direction, resultant is a minus b. Whichever vector is dominant, in that direction only resultant will act. In this figure 30 is dominant, so resultant 20 will come in that direction. Whenever two vectors are in the same direction, resultant is simply a plus b, which means both vectors you can add and resultant vector will be coming in the same direction of a and b. Other than these four cases, you may encounter a new angle. Maybe they will give you 120 degree, maybe they will give you 60 degree, maybe they will give you 30 degree between vector a and vector b. Doesn't matter. Other than any these three you are getting, directly you apply our general equation. Okay, always we cannot apply general equation. It will take a lot of time to solve the problem. That is why we are studying special cases separately. So I hope everyone have some usefulness and everyone understood what is the reason to study special case of parallelogram law. Each and every step in our chapters and our lectures are important. So I am preferring don't skip any portion. You can use 1.5 x speed and all, but try not to skip any portion. On next class, we'll try to do some problems in parallelogram law, some we can say main level question, which was most commonly short answer type question. After that we will move on to advanced type questions also. I hope this is very useful. Thank you everyone.